Hello, I'm Simon Whistler. You're watching the Today I Found Out YouTube channel, and in the video today we're looking at what is the hottest temperature possible. The idea of absolute hot springs from its better-known cousin, absolute zero, which, as you may recall, is 0 Kelvin, or minus 273.15 Celsius, or minus 459.67 Fahrenheit. And although abridged definitions of the lowest temperature will frequently state it is the point at which matter stops moving, this is technically incorrect. Absolute zero is actually the point where molecular motion no longer produces heat, but does have zero-point energy. Conversely, absolute hot then could be defined as the point where molecular motion couldn't produce any more heat, no matter what the circumstances. In the standard model of the universe, the hottest possible temperature ever reached occurred a fraction of a second, 10 to the power of minus 43 after the Big Bang. During that minuscule period of time, called one Planck time, the universe is thought to have been one tiny Planck in length, that's 10 to the power of minus 35 meters, and have reached absolute hot at 10 to the power of 32 Kelvin, called Planck temperature. For a comparison, our Sun is a measly 1.571 times 10 to the power of 7 Kelvin at its center, and the highest temperature ever created by man is 5.5 times 10 to the power of 12 Kelvin. Beyond Planck temperature being the hottest temperature ever theoretically reached in our universe, physicists have hypothesized that any temperature higher than Planck and the gravitational forces of the affected particles would become equally as strong as the other fundamental forces, electromagnetic and weak and strong nuclear, resulting in all four becoming unified as one force. So what happens then? Nobody knows, as currently accepted conventional models of physics break down after that point. Of course, all of this is theoretical, since no one has yet to come up with an accepted quantum theory of gravity. As Nobel laureate Steven Weinberg described it, whatever happens at temperatures above 10 to the power of 32 Kelvin remains obscured by a veil. It should be noted that not all physicists follow the standard model, and some prefer, for instance, string theory, which attempts to describe all four fundamental forces as different manifestations of a single basic object, a string. For string theorists, the highest possible temperature is far lower than that postulated by the standard model. Called the Hagedorn temperature, it is the point at which ordinary matter is no longer stable and either evaporates or changes into quark matter. Under this theory, the point at which that happens, or absolute hot, is thought to be just 10 to the power of 30 Kelvin, or about 1% of Planck temperature. So I really hope you found that video interesting. If you did, please do give us a like below, and don't forget to subscribe. Also, over there on the right are a couple of other videos you might enjoy, and thanks for watching.